This is looking at 7.2 angle relationships in quadrilaterals. So a quadrilateral has four sides. So this is four sides. So that's a quadrilateral. So quadrilateral comes from the word quad, which is four. So four sides. So we're looking at angle relationships in quadrilaterals today. The properties of a parallelogram is what I'm going to start with right now. So a parallelogram, let's go through that word first. So a parallelogram means that the sides are parallel to each other. So this one is parallel to this side. So these opposite sides are parallel. How do we indicate parallel? We use little arrows. So this double arrow here and this double arrow here, that means those two are parallel. It matches them. It matches them together. Then these opposite sides here are also parallel. So this arrow and this arrow like this, those are parallel to each other. So when they're matching in, doesn't have to be in color, but matching in numbers. So these double ones are parallel, these single ones are parallel with each other. If it's a parallelogram, so that's the definition of a parallelogram, that the opposite sides are parallel. If it is a parallelogram, then that means these opposite angles are equal. So this angle equals this angle. So sometimes we use these little circles or dots to indicate same, same. The other one here is that this equals this, right? And you can do a line saying that line equals this line. So those opposite angles are equal. So opposite angles are equal. Those opposite. So this one and this one, those are opposite angles are equal, and this one and this one. And you can even see it on the diagram how they are very symmetrical. The next one, I'm asking you, by using two triangles, what can you conclude of the interior angles of a quadrilateral? So this is a quadrilateral. So first of all, start with a quadrilateral. I just drew a general one. So it wasn't special. It's not a rectangle, not a square. If I cut this quadrilateral in half, so if I cut this quadrilateral in half, either way, so I can do it corner to corner, or not in half, sorry. If I cut it, not in half, just corner to corner, or this corner to corner, so either corner. Doesn't matter which one. So it's corner to corner, not in half, but just corner to corner. So I'm cutting the quadrilateral. That will make up two triangles. Can you see the two triangles? We've got one triangle here. Okay, so that's one triangle there. And then we have the next triangle here. So taking a quadrilateral and cutting it will create two triangles. So I have two triangles there. So these two triangles, each one of these triangles is made up of 180 degrees on the vertices. So if I add this angle to this angle to this angle, those three angles will equal 180. If I do the same thing with the pink triangle, so this angle, we'll call this one here 2, 3, that angle, and then I don't know what other symbol to use. I'll just use a, a double check. Okay, that double check there, that angle there. So all of these angles are touching together, so that means that I have 180 plus another 180. So 180 from the pink one, and then 180 from the yellow one. So that means every quadrilateral will be two triangles, which will be 360. So I know that the sum of the interior angles of a quadrilateral is actually two triangles, so it's going to add to be 360. Okay, and this is what you want to memorize, that it adds to a 360 for a quadrilateral. Now, the exterior angles of a quadrilateral. So here I drew a quadrilateral, and I extended each side a little bit. So a little bit longer, a little bit longer, a little bit longer, and then a little bit longer. So I took each side and extended them up, just pulled a little bit. Now, again, this is like the one I did with the triangles. Imagine that these are strings, and I was going to pull each one the same amount. I could make a smaller quadrilateral. So if I take this line here, and this line here, this line here, and I take each one of these strings and pull it tighter. So I'm pulling each one of the strings just to tighten this quadrilateral up to make it smaller, and I keep pulling. By the time I pull really, really tight, it's going to end up being so that the quadrilateral is so small. See, it's there? It's in the tiny, tiny there. This is all going to equal 360. So if I add up all of these exterior angles, so that means if I add up this one, with this one, with this one, with this angle here, all of those are going to add up to be 360 because this is the dot, check, one line, and then the double line there. So if I add up all of these 4 angles, I put them together and I pull the string really tight. It's like I said with the other example, it's like a hood. So if I take it, or a bag, if I have a drawstring on each one, I'm going to take it and I'm going to make it really small. I'm going to put it all together. It's like a drawstring, and it puts it together in the middle, and it's a 360 all the way around. So the exterior angles of a quadrilateral is 360. The interior angles of a quadrilateral is also 360. All right, so let's see if we can use that. Oh, wait, one more theorem right here. So using diagonals, so now the next theorem, and then we're going to use this in some questions. So I'm going to go through all the theory first. Using diagonals and the sum of the angles of a triangle, how can you find the sum of the interior angles of a regular hexagon, octagon, or any shape? And how can you find each angle? So these shapes have names. Regular means, so if I said regular, then that means all the sides are the same length. So same, so if I use the word regular, regular means same length. If I just say hexagon, it doesn't necessarily mean same length. Okay, so this one here, I made this side a little bit longer. This one's a regular. This is just an octagon. This is regular. So if it doesn't say regular, it's not the same length. For this one, they're all the same length, and it's a hexagon. Hexagon means 1, 2, 3, 4, 5, 6 sides. So this is 6 sides. So this one here, it's a regular hexagon. So it has 6 sides. So 6 sides. So this is just my brain thinking this. This is hexagon. I'm thinking this. So if I have 6 sides, I want to cut this into triangles. Right, so you can cut this into whatever triangles you want. So I'll start anywhere. So I'm going to start it over here. I'm going to cut it into a triangle any way you want. So how would I go corner to corner here? So one here. Then I'm going to cut it again. So I'll cut it any way I want. So I'll cut it from out here. Then I want to cut it again, and I'll connect it to here. So if you cut this up, when you slice it up, I'm going to get 4 triangles. Do you see how I got 4 triangles out of it? 1, 2, 3, 4. So there's triangle 1, 2, 3, 4. 1, 2, 3, 4. Does that make sense? You can see this is 1 triangle, 2, 3, 4 triangles. So there's 4 triangles. That means I'm going to get 4 times 180 degrees, which I get 720 degrees. So that means the whole thing adds up to 120. So all of these angles inside of the hexagon, this angle, all of these angles add up to 720. How many angles do I have? So let's count. 1, 2, 3, 4, 5, 6. Does that make sense? You have 6 angles because it's 6 sides? 1, 2, 3, 6 sides, or 6 angles. So I know that the whole thing, if I added all those blue ones up together, they all add up to 720. If I want to find one angle, so it says, how can you find each angle? So if I wanted to just find this corner right here, how do I find that corner? I know that there are 6 of them, so I would do 720 divided by 6, which gets me 120. So that corner, each one of the corners is 120, and when I add them all up, it adds to 720. So that is our new theory whenever we have any shape. It doesn't have to be regular, right? So regular means that they're all the same, but it can be just any shape. So octagon, the octagon that I showed here, is oct, which is 8 sides. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 sides. Can we try to cut it into triangles again? So start at any corner. So I'll start at this corner here. I want to cut it again, so any way you want. So I'm going to cut this into another corner, and then you can cut this. You can cut this one here, and you can cut it any way you want. So any way you want, how many triangles are you going to get? How many triangles are you going to get? So if I count it, look, and I even did a zigzag triangle. 1, 2, 3, 4, 5, 6 triangles. So 6 triangles. So no matter which way you cut it, you should have gotten 6 triangles out of this. If I know it's 6 triangles, it's going to be 6 times 180, which gets me 1080. So 1080 for all of these angles added up together. So that means I added each one of these corners up, all of those corners, and it adds to 1080. I didn't say it was regular, so I can't cut it into 8 and get each one. And you can see this line is actually a bit longer. But I know that the total is 1080. So my conclusion from this is, if you notice the pattern, whenever you're looking for the sum of the angles of any shape, it's going to be 180, and it's always, if it's 8 sides, there will be 6 triangles, so n minus 2. So this is where you get the n minus 2. So that'll be the number of triangles. Number of triangles times 180. So here I had 6 sides, but there's going to be 4 triangles. So 4 times 180, you get the full amount. Okay, so that is the theory with any shape. You can cut it into triangles, and you can do 180 times each triangle. Okay, so that's it for the theory. And now we're actually going to try to calculate a few things. So on the next page here, we're looking at missing angle measures. So find the missing angle measures. Here, it's a quadrilateral, so I know it adds to 360. So what I'm going to do is I'm going to go 360, right, that's what I start with, minus the 92, minus the 108, and minus the 81. And when you put that into your calculator, you're going to get the missing angle x. And when I put that in my calculator, I get 79 degrees. Please make sure you put degrees wherever it's degrees. Okay, you have to have the units. You have to have the units. All right. For the next one, this is the exterior angle. So what you're picturing is that I'm pulling the strings really tight. It's going to make a circle. So again, I'm going to do 360 minus, and this will be 88 minus 110 and minus 94. And that would get me 68. So that means that that angle there is 68 degrees. Okay, so that's the exterior. So that's, again, the theory we just learned. Okay, so every quadrilateral adds to 360. All the outside of a quadrilateral add to 360 as well. Here, if I give you these symbols, you have to realize these dots here mean the same angle. So if this angle equals this angle, and we know every time I get any straight angle, I know a straight angle always adds to 180, just like the protractor, like that little ruler. So we're going to go 180 minus 117, and that gets me 63. And I want to take the 63 and break it up. So then I'm going to go 63 divided by 2, and I get 31.5. So each one of these is 31.5 degrees. Are you allowed to have decimals? Yes, you are. Sometimes an angle will be a decimal, so that's okay, 31.5 degrees. So 63 degrees divided by 2. It's okay to be a decimal. So always remember that 180, though. Okay. So hopefully it's going to get easier the more we do. This next example, I have a quadrilateral, so I know that that adds to 360. I have a triangle, and I know that adds to 180. So I want to find x. I don't know if I need the triangle. So I have 102, I have 90, I need this angle. Oh, I do need this angle. So what you do is, if you don't know how to start a question, I recommend filling in whatever you do know. So it doesn't matter if it helps or not, as long as you start to work at something, something will help. So if these are all the same, right? We know that they're all the same, and we said that this is an equilateral. So this is an equilateral triangle. You don't need to write that, but that's your brain. Which meant it was 60, 60, and 60, all 360. Okay, so they're all three of them are 60. Then I go, how does that help me get to x? We'll just start filling in more. As soon as I see a straight line like this, it's a perfectly straight line. So then this is going to be 180 minus the 60. So for this angle, 180 minus the 60, which gets me 120. So now you filled in as much as you can. Now look back at your quadrilateral. I know a quadrilateral adds to 360, so I'm going to go, so this is my brain thinking this. So I go 360 minus the 120, minus this corner here, 90, and minus 102. Okay, when I do that, I get exactly 48 degrees. So I know that this x is 48 degrees. So this is 48 degrees. Okay. We love to use different shapes other than quadrilaterals and triangles because we can finally use that. So this is a pentagon, like this, pentagon. And we know that a pentagon, oh, it says regular. I was going to say, I wish that I knew if it was regular. So we do know it's regular. So if it's regular, that means all the angles and sides are the same. So for a pentagon, if it's 5 sides, so here, let's write this down, 5 sides. 1, 2, 3, 4, 5. So you don't need to know the word, but you count your sides. So 5 sides. How many triangles will it be? It's always 2 less. So the theory that we had over here is that it will always, if it's 6 sides, it's 4 triangles. If it's 8 sides, it's 6 triangles. You can even try to cut it up. So if you look at it and go, how many triangles can I cut this up into? 1, 2, it would be 3. So 3 times 180 equals 540. There's a formula as well. So the formula says, formula is that it's always going to be 180 times n minus 2. N is the number of sides. So if I know that it's 180 and I know there's 5 sides, it's 5 minus 2, which is 180 times 3, which is what I have right here, 180 times 3. So you can use the formula. Sometimes that is useful, and sometimes you just go, but I know it's 3 triangles, because if I cut this up, it'll be 3 triangles. That gets me 540. Because I told you it's regular, then you can divide it evenly. 5 corners, 1, 2, 3, 4, 5. So divided by 5, and that gets me 108. So I know that each of these is 108. Fill in the one closer to your x's, so this will be 108 degrees. 108. If those two x's are the same, so that's why I labeled them the same, then what we can do is we can say, okay, but I know that this is a full circle. At that corner, all 3 tuck in the same, so they're all going to make a full circle. So then for the circle, so we're going to do 360 minus 108, and this is for the circle, right, for the circle right there. So that'll be 252 degrees for the whole thing minus this corner. So then that means that these 2 x's must be, so 252 divided by 2 is 126 degrees. So each one of these is 126 degrees. So this side here is 126, and this side here is 126. And look, when they add all up, it makes a full circle. 126 plus the 108. Okay. So when you're not sure, just start to fill in all the angles that you can find. Okay, for this one, we love to ask you this question as well, because it's not a quadrilateral, it's not a triangle, but for this general shape here, how many sides does it have? Some people say it's a quadrilateral, but count. 1, 2, 3, 4, 5 sides. If it has 5 sides, then you either go to your formula, which I said here, or you know that it'll be 180 times 5 minus 2. So that'll be 5 sides means it's 3 triangles. And if you cut it, it's 3 triangles. So it's 180 times 3, which is 540 degrees for the whole thing. So this whole thing adds up to 540. It's the same as this one. But this one, look, I said was regular. The same. That's not regular. It definitely doesn't look regular, and I didn't say it was regular. So regular pentagon, not regular pentagon. Regular means all the same, every angle's the same. Here, they're all mismatched. So they're both 5 sides, they're both pentagons. This is regular pentagon, not regular pentagon. Okay, so then to find this one, it still adds to 540. So for both of these pentagons, it's 180 times 5 minus 2, so 540 degrees, both, right, both of them. But this is regular, so I can divide it and cut it. Here it's not. But I'm still going to take the 540, and I'm going to go 540 minus, and I'll subtract all of these. So minus 91, minus 93, minus 155, and minus 52. And that would get me my remaining x, which gets me 149. So this is 149 degrees. Okay, so regular and not regular is very important. Still the same kind of formula here, but then how you deal with it is a little different. And it really is just practice. So the more of these questions you do, the more practice you do with a lot of these shapes, you start to just know it's 180, it's 360, I'm subtracting, I'm adding, I'm dividing. It becomes very, very second nature. So please, please practice. And the more you practice, it'll become very, very, it becomes much more straightforward. Okay, but practice so that, and again, my hint is, if you don't know how to get to the unknown side, just start to fill in everything else. And eventually you'll get so close, you'll be like, oh, I know how to get it. So fill in all the missing angles you can. Fill in as much as you can, and it'll eventually get you to your answer.